This is a Toyota 1UZ engine from a 1994 Lexus SC400. I'm going to run it on the stand here just to check its condition, as well as the condition of some modifications I've made. So I've got the wiring harness all stripped down to just engine control, just the ECU and just what's needed to run it in its factory configuration, I should say. I don't have, these are not the relays and fuses I'm going to be using. This is just a temporary test rig. I'll be setting up a nicer fuse and relay box when the time comes to, which will also house headlight and radiator fan relays, etc. But that's not what this is about. This is just to see if it works. I bought this engine sort of without knowing what the deal is. I bought it already pulled out of a car, which is not usually how I try to do things, but I did this time. So, got the ECU and wiring harness. I laid them up on top of the transmission there to keep the wiring clear of the exhaust, just to make sure I don't melt anything. While I had things apart, I took off the intake manifold and had the starter rebuilt. You can see it buried down in there underneath the intake manifold. Kind of a weird design on this engine because it's an overhead cam engine. There isn't a cam in the middle. It's got a lot of empty space in the valley there, so they put the starter in there. It's kind of interesting. Makes it a nightmare to get to if you need to later. So I opted to do it now, as well as some other gaskets, some hoses, new PCV hose, stuff like that. I removed let's come around this side, I removed the traction control from the throttle body. You can see I've got a pipe plug in there where the motor used to go through, and then on this side where the second position sensor was, I've got a pipe fitting here, and this is now my idle air hose. That would used to plumb into the plenum between the throttle body and the airflow meter, and now it goes in right there. It's kind of a clean setup. It's a guy in Australia, New Zealand, Cartoon NZ, that did that, gave me that idea. That's a fantastic solution. Temporary fuel system here. That is a Subaru fuel pump, because that's what parts car I have in the yard. Hooked up to a chunk of fuel line. Has the factory strainer on the bottom. Little inline filter so I don't clog injectors in this little experiment. Return line is, well, it's not fuel injection line because that's expensive, and this is just a return line. So just a chunk of hose dangling in a bucket there. We'll put fuel in it when the time comes. That is not wired up right now. What I'm going to do, one of the first things I want to do is pressurize the fuel system. One of the things that happened when I had this apart is on this engine there is a 9th injector. It's right under the middle of the intake, the upper intake, down in there. It's called a cold start injector, and it's got a little nylon sort of hard plastic line that runs up to it, which snapped. My solution was to replace it with we got a new banjo fitting to use a larger hose, because the original hose was such small diameter, it was going to be difficult to replace. So I got some fuel injection hose, 1/4-inch fuel injection hose to a new banjo fitting. The downside is the larger hose was hitting the fuel rail underneath it. So underneath, probably no way you'll be able to tell, but underneath it I had to stack an extra crush washer there to keep it square. So that is going to be my number one suspect for fuel leak. So I want to pressurize the system before I even try to do anything else. So I've got, but I do have the factory fuel pressure or fuel pump controller wired in there. I have tested this before I had a multimeter on it before, and I will do so again before I actually start this one. I'll show that. That is all working. I'll show you. I've got a little rocker switch here. This is simulating both my ignition switch and my check engine light. If I flip it on, the little backlight comes on. And if I put it into diagnostic mode, that light will flash codes to me if I want it to. So that is indicating that the ECU is powering up correctly. It is turning on, so one relay is turned on right from that switch. The other one is controlled by the ECU. So that means the ECU is coming on. I have also verified while turning it over with a timing light that it does have spark, though I did not have any fuel supply going to it at the time. In fact, the intake manifold wasn't bolted on, so I wasn't going to try. So the other reason I want to do this is sort of a control test. This engine will be going into my 1987 Toyota 4Runner, which you can see sitting over at the edge of the yard. We'll bring it in when the ground dries out a little bit and the engine's a little more ready to go. Also when my Celica's more ready to come out of the garage, which shouldn't take too long, doesn't need much. That 4Runner, point back at it, has a Chevy 4.3 liter V6 in it. I did have one occurrence with that engine where I had some trouble keeping the heat out of the engine bay. The engine temperature was creeping, and it was heat soaking all the way, like the fenders were hot to the touch. And that was on a really slow technical off-road trail where there's just no airflow. A better fan probably would solve that, but one of the things I want to consider when I'm preparing this engine is underhood temperatures, getting the heat out of the engine bay. And I've stumbled across a product, I believe it's by Eastwood, an internal ceramic exhaust coating that can be done DIY in your own garage. Ceramic coating is not a cheap process, so something I'd like to try. They claim to reduce underhood temperatures. So what I'm going to do is I'm going to run this engine, and I will be using an infrared temperature gun to monitor both engine temperatures and surface temperatures of the two exhaust manifolds. You can see I've got the heat shields off of them. Note to self, I've got some wires here that I need to pull out away from there. That might be all right. We'll take a look at it. And basically what I want to find out at this stage is just make sure that both manifolds heat up at about the same time, about the same rate. As the engine comes up to temperature, I'm going to have a bucket hooked up to the radiator hoses with some coolant in it just to keep the engine temperatures in check. Probably isn't enough to run it indefinitely, but certainly for quite some time. And we'll see if those manifolds heat up about the same at about the same rate, which I assume they should. But I'm going to do a control to make sure. And then what I'm going to do is I'm going to remove one of those manifolds and treat it with that ceramic coating. And then we'll do this test again and see if that manifold is noticeably cooler. Theoretically it should be, but I'm curious. So this is the beginning of that experiment as well. Yeah, I think that pretty well shows you what I'm doing. I'm going to get some more work done, get it a little more ready to go. The igniters, these are the ignition igniters. I found out the hard way, had to be grounded through the bracket. So they're bolted strangely onto the back of the head there. Now that I had to do that to get spark. That will be mounted over in the fender on the wheel well in the truck when the swap happens. Of course, it's not going to sit there. As well as heater core lines are looped, and there's some strange things happening here for this test, but I think it should work out all right. Yeah, so I'll get it a little more ready, and I'll hit record again before I start it. was going to just check for spark, but I had the fuel pump on. So it's already run for a little bit. But I'll show you what I got going. Now the fuel pump was hardwired. It is now wired to our controller through the harness. I do have a multimeter on that output. That controller is able to vary the voltage going to the pump. So I'd like to watch that. That's about it. Let's start it back up. My battery charger seems to be on the fritz, so I got one of these little jump packs. Hopefully that'll be enough. Turn the ignition on. Light comes on. Spectacular. Fancy starter. Loud, even open headers. Well, until you do this. Way cool. Thermostat's starting to open up. Seeing 160 or so on the housings, or getting a little drip of some fresh coolant. Check those headers, those manifolds. Between 400 and 430. How about this one? Watch that multimeter, flip the switch off, 0. Shuts fuel off. That is awesome. Sweet.